Hello, so this is my report. Factors affecting alternator regulation. Three factors which influence the terminal voltage of an alternator: the effective resistance, the leakage reactance, and the armature reaction. So the focus of my report will be on the effective resistance because the leakage reactance and armature reaction will be reported by another reporter. Effective resistance. The effective resistance of an armature winding is greater than the conductor resistance measured by direct current. This is because additional energy over the purely I squared R value is expanded inside and sometimes outside of the conductor, owing to the alternating current. The chief sources of this additional energy loss are, so this is the sources where the additional energy loss is in. The eddy current in the surrounding material, the magnetic hysteresis in the surrounding material, and the eddy currents or unequal current distribution in the conductor itself. So as you can remember, the eddy current and hysteresis was reported in our midterm. So the eddy current conductive I squared R loss produced by circulating currents induced in response to AC flux linkage flowing against the internal resistance of the core. And the hysteresis loss is the heat loss by magnetic property of the armature. It occurs due to the reversal of magnetization of the armature core. So these are the three sources of the additional energy loss. In many cases, it is sufficiently accurate to measure the resistance of an armature by direct current and increase it to a fictitious value called the effective resistance, Re, which is large enough to take care of these extra losses. The exact value can vary widely from 1.25 to 1.75 or more. X, the DC resistance, depending upon design. Extremely accurate is not necessary in this factor for calculating regulation, since the voltage change due to resistance is small in comparison to the changes produced by leakage reactance and armature reaction. Generally, the armature resistance is measured by applying the known DC voltage and measuring the DC current through it. The rate of applied voltage and measured current is the armature resistance, but due to the skin effect, the effective resistance under AC conditions is more than the DC resistance. While measuring the armature resistance, it is necessary to consider how the armature winding is connected, whether in star or delta. Considering a star-connected armature winding as shown in figure 1. So as you can see here, it is a star-connected alternator. This is the star or the Y. When voltage is applied across any two terminals of an armature winding, then the equivalent resistance in the series combination of the two resistance of two different phase winding. RY resistance between RY terminals, and it is equals to the R sub A plus R sub A, or R to R sub A, where the R sub A is the armature resistance per phase. Thus, in a star-connected alternator, the armature resistance per phase is half of the resistance observed across any two line terminals. Consider the delta-connected alternator as shown in Figure 2. So this is the Figure 2, and as you can see, the delta-connected alternator. Here's the delta. Next is, when voltage is applied across any two terminals, then one phase winding appears in parallel with series combination of the other two. Hence, equivalent resistance across the terminals is parallel combination of the resistance R sub A and 2R sub A. Thus, in delta-connected alternator, the armature resistance per phase is to be calculated from the equivalent resistance observed across any two line terminals. Okay? So, for the conclusion, three factors which influence the terminal voltage of an alternator with increased load have been dealt with. So there is this excitation and speed being considered constant. Okay, so in the effective resistance of the armature winding, causing an armature voltage drop IR. Okay, so for the leakage reactance and the armature reaction, this will be reported by the next reporter, but I include some of the information here. So the leakage reactance of the armature causing an armature voltage drop by X. So since is X, this is reactance. Armature reaction causing a change in the effective air gap flux, which in turn affects the voltage. The effect of this armature reaction will be calculated and expressed as a voltage drop Ix. Okay, so that concludes all my report. Thank you for listening.